The universe has been expanding for nearly 14 billion years. But will it last forever? Or is there an inevitable end? Scientists believe the universe will have an end, and when that moment comes, everything, every galaxy, every star, even space and time itself, could disappear. But how will it happen? Will the universe collapse in on itself? Will it stretch until everything fades into nothingness? Or could something far stranger await us at the end of time? There are several possible fates for the universe, each more mind-bending than the last. Some predict a slow, inevitable freeze, while others suggest a violent, catastrophic event that will erase everything in an instant. So, how will the universe meet its ultimate fate? And what will remain after everything is gone? The universe is not a static place. From the moment of the Big Bang, nearly 14 billion years ago, space has been expanding, carrying galaxies farther apart. But while we've observed this process for decades, the biggest question remains: will it ever stop? Or are we heading toward an inevitable end? To understand what the future holds, we need to examine two fundamental forces at play: gravity and dark energy. Gravity is the force that holds the universe together. It keeps planets orbiting stars, binds galaxies into clusters, and resists the expansion of space itself. If gravity were strong enough, it could eventually overcome this expansion, slowing it down and perhaps reversing it entirely, causing the universe to collapse in on itself. Dark energy, on the other hand, works in the opposite direction. It is a mysterious force that seems to push the fabric of space apart. For centuries, scientists assumed that gravity would be the dominant force in the universe's fate, gradually pulling everything back together over time. But that changed in the late 1990s, when astronomers studying distant supernovae discovered something shocking. The universe's expansion is not slowing down, it's speeding up. This discovery turned our understanding of cosmology upside down. Instead of being on a path toward a gravitational collapse, the universe appears to be dominated by dark energy, driving galaxies farther apart at an ever-increasing rate. This acceleration suggests that, rather than ending in a fiery collapse, the universe may continue expanding indefinitely. But if that's the case, what happens to everything in it? If galaxies drift apart faster than the speed of light, if stars eventually burn out with no new ones forming, what will remain? Some scientists believe this scenario leads to the Big Freeze, a slow, quiet death where the universe fades into darkness, drained of all energy and heat. Of course, that's just one possibility. There are multiple theories about how the universe might meet its end, each with different consequences. So, what does the future really look like? If the universe continues expanding forever, then over unimaginable timescales, something catastrophic will happen, not suddenly, but gradually, in a slow decline into nothingness. This is what scientists call the Big Freeze, or the heat death of the universe. At first, things won't seem much different from today. Galaxies will keep drifting apart, stars will continue to burn, and planets will still orbit their suns. But over billions and trillions of years, the expansion will stretch the universe to the point where galaxies become completely isolated from each other. Then comes the first major problem. Star formation will stop. Right now, new stars are born from giant clouds of gas and dust that collapse under gravity. But as time passes, these raw materials will run out. The last generation of stars will form, burn through their fuel, and die without new stars to replace them. At this point, the universe will start to go dark. First, the largest and hottest stars will burn out in just a few million years. Then, the smaller sun-like stars will fade after several billion years. Eventually, only the slow-burning red dwarfs, some of the most resilient stars in the universe, will remain. But even they won't last forever. The final red dwarfs will flicker out after trillions of years, leaving behind only black holes, dead stars, and frozen planets drifting in an empty, lifeless cosmos. But the Big Freeze doesn't stop there. Even after all the stars are gone, matter itself isn't safe. Over incomprehensibly long timescales, subatomic particles may start to decay, dissolving into radiation. Even black holes, the most enduring objects in the universe, will eventually evaporate through a process called Hawking radiation. At some point, all sources of energy will be gone. The universe will be nothing more than a vast, empty expanse of space, filled with cold, fading remnants of what once was. No heat, no light, no life. Just an eternal, inescapable void where nothing new can ever form again. It's a bleak future, but is it the only one? Could the universe meet a far more violent fate? While the Big Freeze envisions a slow, quiet death, the Big Rip suggests a much more chaotic and violent end. Instead of simply expanding forever, the universe's acceleration could eventually become so extreme that it tears itself apart, literally. This all depends on a mysterious force known as dark energy, which makes up about 70% of the universe and is responsible for its accelerating expansion. Right now, galaxies are drifting away from each other faster and faster. But what if this acceleration keeps increasing without limit? In the Big Rip scenario, dark energy doesn't just push galaxies apart, it starts affecting everything. At first, the expansion would stretch galaxy clusters until they break apart. Then, individual galaxies would be ripped apart, scattering their stars into the void. But it doesn't stop there. As the acceleration continues to intensify, solar systems would unravel. Planets would drift away from their stars, moons would escape their planets, and even atoms, the very building blocks of matter, could be ripped apart by the relentless force of dark energy. Eventually, even space-time itself would be shredded. Gravity, electromagnetism, and the fundamental forces that hold the universe together could be overwhelmed, reducing everything to a featureless, structureless void. The universe wouldn't just end, it would be obliterated. This catastrophic fate could unfold much sooner than the Big Freeze. Some estimates suggest that if dark energy becomes more powerful over time, the Big Rip could happen in just 22 billion years, a fraction of the universe's total lifespan. But what if neither of these fates come true? What if, instead of stretching endlessly, the universe collapses back in on itself? Instead of expanding forever or being torn apart, what if the universe reverses course? That's the idea behind the Big Crunch, a scenario where gravity eventually overpowers dark energy and pulls everything back together. For billions of years, galaxies have been moving apart. But if the expansion of the universe slows down and reverses, everything would begin to fall back inward. The process would start slowly, with galaxies gradually drifting closer together. Over time, the night sky would begin to change. Galaxies that once appeared distant would start to merge, forming massive superclusters. Then, the process would accelerate. The cosmic web, the large-scale structure of the universe, would begin collapsing. Black holes, stars, and planets would all be drawn together by the growing force of gravity. As the collapse continues, the universe would become hotter and denser. The background radiation that has been cooling since the Big Bang would start heating up again. Temperatures would rise to unimaginable levels, and the energy released would ignite space itself. In the final moments, everything would be compressed into an incredibly small, infinitely dense point, a singularity. Essentially, the universe would end the same way it began, potentially triggering another Big Bang in a never-ending cycle of creation and destruction. But there's one more possibility. What if instead of collapsing or expanding forever, the universe simply tears apart the very fabric of reality itself? The idea of the universe collapsing in on itself might sound like the ultimate end. But what if it's just the beginning of something new? Some physicists believe that instead of a final collapse, the Big Crunch could trigger a rebirth known as the Big Bounce. In this scenario, when the universe contracts into a singularity, it doesn't just end, it explodes outward again, creating an entirely new universe. This cycle of expansion, collapse, and rebirth could have been happening forever, meaning our universe may not be the first, nor the last. If this theory is correct, the universe could be oscillating endlessly, with each cycle erasing the previous one and creating a new reality with different physical laws, different galaxies, and perhaps even different versions of existence itself. But how could this happen? The key lies in quantum mechanics, the strange rules that govern the smallest particles in existence. Some theories suggest that at extreme densities, quantum effects could prevent the universe from collapsing into a singularity. Instead, a new expansion would begin, much like the original Big Bang, but with new cosmic conditions. If true, this would mean the universe has no real beginning or end, just endless cycles of creation and destruction. But whether the universe dies in silence, collapses in fire, or rebounds into something new, one thing is certain: we are watching history unfold in cosmic time. But what does that mean for us? One way or another, the universe will come to an end. Whether it freezes, collapses, or tears itself apart, the fate of everything we know is already written into the fabric of space and time. Each theory offers a different vision of the future. The Big Freeze paints a picture of an empty, cold universe where stars fade and nothing new can form. The Big Rip suggests a far more violent fate, with galaxies, planets, and even atoms being torn apart. Meanwhile, the Big Crunch and Big Bounce raise the possibility that the end of our universe could lead to the birth of another, part of an infinite cycle of creation and destruction. No matter which scenario unfolds, one thing is certain: we are living in just a brief moment of cosmic time. The universe, vast and seemingly eternal, is constantly changing, and while its end may be billions or trillions of years away, every discovery we make brings us closer to understanding how it all might conclude. So, will the universe end in fire or in ice? Will it collapse, freeze, or be reborn? And what, if anything, will remain after everything is gone? Join us next time as we explore more mysteries of the universe.